Now what happens when you keep on studying for long hours? You say we are tired, we are saturated. Now what is this saturation? Actually this word we use also for solutions. You dissolve some sugar in water, it disappears. You add more, again it disappears, till it refuses to get dissolved anymore. Now when no more solute can be dissolved, then it is called saturated solution. Why? Because the space between the molecules is fully filled with the solute particles. Now what is the way out? You want to add more. You heat it a little, some more sugar will get dissolved. Why? Go back to your molecules. The moment molecules get more heat energy, their kinetic energy increases and they move away from each other, which in other words means more space gets created, and so more solute can be dissolved. Now after we have heated it, if we cool it, now actually space was not there, but everything has got fitted in. Now this is supersaturated solution. Like it happens in a compartment of train, especially the unreserved one. When a lot of people come in, somehow initially there is a lot of trouble. They don't get adjusted. But slowly, let 2-3 stations pass and then everybody gets fitted in. Isn't it? That's exactly what happens supersaturated solution. The moment they are fitted into those spaces, then even if we cool the temperature, they remain fitted. Now going back to our second solution, not solution, now we will not use the word solution, the second beaker. You had put chalk powder in it. Can you see the particles? You can. So if you can see the particles, is it a solution? No. It is suspension. So the most striking feature about a suspension is the particles are large and can be seen. Now because they are large, if you will throw a beam of light, it will be scattered. You will be able to see the particles. Right? Now take another case where there was milk. The entire liquid looked white. Actually, milk is not a homogeneous, you can say, or it is not one substance. It is another form, and that is, it is a colloidal solution. Colloids. The colloids are in a way in between suspension and solution. The particles are larger than that of solution, but still they cannot be seen. But they are large enough to scatter the light. Now sometimes early morning if you go to a forest or you go to a hill station, how the sun rays trickle out of those misty air, that effect can be seen in the case of colloids. And that effect is called Tyndall Effect. Now the chalk powder, when mixed in water, you let it stay. After some time it will settle down. So it is an unstable mixture. But in the case of colloids, it will not. So it is a stable mixture. A peculiar thing about a mixture is that the components do not lose their individual properties. Though they stay together, it is something like India. We all Indians who speak different languages, who have different culture, but still they stay together. But still they also retain their individual culture. So a mixture is something like that. If required, we can easily separate them through their language, through their habits, behavior, and certain rituals. We can easily separate them. Similarly, in a case of mixture, the components can be separated by their physical properties and by simple physical processes like boiling, hand picking, sieving, and so on. If the components are small in size or different in size, then we can do sieving. Like say if wheat and rice are mixed, we can sieve. The bigger particles will remain on the sieve, smaller will pass through. And same is the process in case of filtration. If the color is different, shape is different, then we can hand pick and so on. So by choosing a physical property difference, we can separate mixtures. So mixtures can be separated by physical processes. And what is the basis of those physical processes? Differences in the physical properties. That could be difference in their weight, in their size, shape, color, melting point, boiling point, and so on. Now, the simplest method you can say is in the case of how we prepare salt. You remember Gandhiji went for Dandi March because we wanted to make our salt ourselves from sea water, and Britishers were imposing on us that we import it. So what did Gandhi do? He took some sea water and allowed it to evaporate, and what was left was salt. So one simple method of evaporation can help us separate a solute from its solution or a solid from a liquid. So you can take in a watch glass salt solution. When you will heat it, then water will evaporate and what will be left is just salt. So near the sea there are alleys or the pits. When high tide comes, sea water gets collected. Over a period of time, water evaporates and salt is left behind, which is collected, but it is not pure form of salt. Now, if we want pure form of salt, we have to do something else. So then the next thing that can be done is we can do filtration. By filtration, we dissolve that salt in water, filter it, so the dust particles and other things remain on the filter paper, and then we get pure salt solution, which is then evaporated and we get pure salt. There can be another way of getting pure form of a solute, like say copper sulfate. You take some copper sulfate, dissolve it and then evaporate so that it becomes a saturated solution. You leave it for a while and what you will get is copper sulfate crystals. This method is called crystallization. By this method, we can make crystals of, say, alum. A saturated solution of alum is prepared in a beaker. Then we hang a small crystal of alum in it and heat it. Slowly, slowly the crystal will increase in size because all the alum dissolved in water will get deposited on the alum. Or you take copper sulfate solution, heat it, it will become saturated solution and then it will change to crystals. So this method is used to get pure form of a solute. So second advantage of crystallization is preparation of pure salt and getting crystals of alum or copper sulfate. This is another method for separating substances. In the case of suspension, what we found that particles or the solute were heavy. So they settled down, right? So in that case, the particles were heavy, so they settled down, and we can use the method of sedimentation. That is how we purify water, or muddy water can be made purer if we use the method of sedimentation. But what if the particles are not heavy? Just as in the case of milk, we say that it is a colloidal solution, and the particles are not so heavy. They are there. It is not a suspension. Then what do? You know what milkmen do when they want to sell you cream? They just churn it, like you churn your things in mixie. When you want to make cold coffee or you want to make lassi, what you do? You churn the mixture in a mixer. And if you continue to do so, if there is malai that you have collected, and if you continue to churn it, after some time, butter separates from the buttermilk. And butter is lighter in weight, so it will not settle down, it will come on top. This method is called centrifugation. Centrifugation means force is moving outside. So when in a mixer, it is the liquid or the mixture, liquid mixture is mixed, then the solid particles float on top. So what is the application of this method? Separation of butter from milk. This method is also used in certain tests like blood and urine test. And same procedure is used for in the washing machines. In fact, in Punjab and Haryana, many farmers use washing machines for separating butter from milk because it is in large quantity. Mixer will not be good enough. So the principle for the mixer or the washing machine is same.